we go. So what did we learn yesterday? I'm just going to give you a quick overview, right? We learned that if you increase or decrease, right? If you have your original and use a scale factor to make something bigger or smaller, enlarge it or decrease it by anything, right? So if you increase or decrease every dimension by the same number, we notice that the areas, right? The areas and the volumes are not affected by this number. They're affected by what? When you're talking areas, they're going to be affected by k squared. Make sure you follow along, okay? And the volumes, this is on page 33, the volumes, if I ever ask you how have the volumes been affected, you don't just say k, which in this particular example was 2, right? You say k to the power of 3. The volumes are affected by k cubed, okay? So that's something that I want you to remember. So let's go back to 38, sorry to jump back and forth. And here we had a question where we would use the wording original and new. That's the best way to do this. I gave you a diagram because a lot of us like visuals, right? And what we realized with this first example is that we knew both of their volumes. So that is the key here. That's why I used this formula to get me started. And I plugged in the new and the original. And first and foremost, make sure you do what's inside the root. I had to cube root both sides, okay? And I get this. Now, for some reason, okay, pay close attention to this part. I wouldn't copy this necessarily, but this is a common error, okay? I don't know why. I don't know why students do this. I'm trying to figure it out. But they'll do k cubed is 500 over 355, okay? And then what they do is they cube this side. And they miraculously get rid of that cube, and then they come up with like this ginormous number, right? If you go 500 cubed, you get that, and then 355 cubed, you get that. So I don't know why students do that, but this is not right, okay? You never, pay close attention to this, you never cube the right side, ever. The only time you would cube is on the left side if you know what k is. If you know what k is, you put a number in there, then you need to cube it, right? But if both of these numbers are known and you're dealing with volumes, right? Given that it is k cubed, you're going to have to cube root both sides. So that's something that I need you to remember. Okay, so I looked around yesterday and most of you are getting these numbers. So for surface area, I need to use k squared, surface area of new and original. I know what the scale factor is at this point. So I go 1.12, and some of you use the math fraction and you turn this into a fraction. That's fine. There's no problem. But I want to show you that you can use decimals. I know this one. And I do not know the surface area. Sorry, I mixed this up, right? I'm making a mistake right now. I did that on purpose just to make sure. But nobody stopped me, so please stop me. I don't know the new surface area. I do know the original. So this is my unknown. And here you have to go 322.57, right? Because it's the surface area of the original. A few of you use 355, so watch it. 355 is volume. And so what I do here is I square. And what I do here is, because it's a decimal, I turn it into a fraction like that. You put a 1 underneath. It doesn't affect it. It's still the same number. And so we square 1.12. That gives us that number. 1 point, do not round when you do something like this. Keep all the numbers as they are, okay? You can go dot dot if you don't want to write out the whole thing. that is just fine. So then we continue. We would cross multiply and divide here. So this is 322.57 multiplied by 1.2544. And then we divide by 1 technically. I'm not going to bother. I'm just going to go 322.57. And so this is 404.63. And we are talking area. So this is centimeters squared. In general, you're not going to have to convert, but if you ever have to, like let's say they wanted this in squared meters, then obviously you'd have to take the extra step to convert this. Okay. Next, determine the height of the can, of the larger can. The larger can is the new can for us. Okay. So what are we talking? Is this k squared or k cubed? It is just k, because the height is one-dimensional. So I just want you to go this way, right? So new, original. So k is what? 1.12. And the new, I don't know, but I do know the original. We're in centimeters. No need to square, no need to cube, nothing, okay? Just cross multiply and divide. So x is equal to 12.2 times 1.12, and you get 13.66 centimeters. Okay. .664. It's okay if you round more than, if you use more than 2, because it's not dollars. But if it's dollars, 2 max. Okay. Okay. Let's keep going. I'm going to check my key here and see. Yeah, I'll do 39. I think 39, just so you have enough in your notes. You can accuse me of too many examples, but I'll take that accusation. I don't want the accusations like you don't give me enough examples. That one, I don't like that accusation, okay? So here we go. Jasmine is making a kite using a scale. This is a scale because it's the format of a scale, but this is really a scale factor as well. Okay, you just stack them 2/25. No need to convert because there are no units. Perfect. That's how you want it. If there had been units and they were different, make sure you convert. You gotta get rid of the units. They gotta cancel out. The fabric required to build the scale model is 20 centimeters squared. Calculate the amount of fabric needed to build the actual kite. So that means that this is the diagram, right? The model is the diagram because we're using actual here. So I like to use diagram and actual. We're talking area, okay? So this is areas, surface areas. So you need to go k squared is the area of the diagram compared to area of actual. And we do know what k is, so we plug that in. 2/25, make sure you square it right away. And on the other side, I have the area of the model. That's 20 centimeters squared. So this is my unknown. You square the 2, that's 4. You square the 25, that's 625. And you leave this side 20/x. You cross multiply and divide. So I'll do my work over here. X is 20 times 625. I'm already giving you a shortcut, so at the very least, I would like you to show me this step, okay? The intermediate step. Don't just go answer right away. So 20 times 625 divided by 4 is 31.25 centimeters squared. This is the first answer, so that applies. Okay, so technically you can circle this, but we want to convert that. This is for grade 12. I'm doing this because a grade 12 applied. Okay, so you want squared inches. So you know that 1 inch has 2.54 centimeters. So what I do is I square the whole thing. So then you have 1 squared inch, and this is 6.4516 centimeters squared. So now you have squared units, which will allow you to convert this to squared inches. So 1 squared inch, 6.4516 centimeters squared. Cancel that out. And it's essentially divided, right? You go this times 1 divided by whatever you have in the denominator. That's going to give you 484.38 squared inches. So either one is correct. They're both talking about the same surface area. And I'm just going to make a note here, convert, right? Oops. If Jasmine made another kite using 500 centimeters squared of fabric, what scale factor would be required to make that model? Assume the model is using 20 centimeters squared of fabric. Okay, so what we have here is another kite. That would be my actual, and the model is my diagram. So one thing is for sure, this is areas, right? Talking areas. So we're going to start with this. Surface area of diagram, surface area of actual. It's asking us for the scale factor, so we don't know it. We don't know how these are related. So we leave it, k squared. Surface area of the diagram is 20 centimeters squared. Surface area of the actual is 500 centimeters squared, which is perfect. We want that to cancel out. What do we do now? Square both sides. No. Square root. Because your goal is to get rid of that squared. Okay? So you square root both sides. Remember, k is basically square root of. So what I do, you can, as long as you're careful, if you use brackets, you're fine. But I'm going to find out what's inside there, which is 0.04. And then if I square root that answer, I get 0.2. You can turn that into a fraction if you want. I didn't ask for it, so I wouldn't bother with this unless I ask you. So that's 1/5. As a percent, that would be exactly 20%. If you do your homework, it's good. It's a good habit to do all three. If it's a test or a quiz, I wouldn't do it, because if you make a mistake, then you might lose a rounding error. Okay. What does this tell us again? There's a reduction, right? By 80%. So the actual has been reduced by 80%. Actual kite reduced by 80%. So you have to get it to your scale factor to be able to answer that. One last example. A sphere has a volume of 1475 cubic meters. If a replica, I call that, replica is what? New, right? If I use the word replica, a new replica, obviously that's new, has been made with this volume, so we can clearly tell that this has been an increase. Determine the scale factor used. Like they're saying, hey, we don't know what the scale factor is here. Figure it out. We're talking volume. Therefore, we have to use this. K cubed is volume of the new shape that we've created, volume of the original shape. We don't know what K is, so we go volume of new, which is 988,134.77 cubic meters and 1475 cubic meters. I'm kind of stuck here, right? So I need to get rid of the cube, so I go cube root. That cancels this out. K is cube root, and I figure that out first. I like to show that as part of my work. That's 669.92, and that keeps going. You know how to access cube root? Math, fourth option. Copy, paste, 8.75. K is 8.75. If you multiply that by 100, that's 875%. Can you turn that into a fraction? I haven't even tried. No, you can't. So we're kind of stuck there. That's what we have. So that's a 775% increase. I like to have that explanation because we went from 100 to 875. So it has been increased by 775%.